In this video, we will write a function for linear search, the one which we have already discussed. I will show you iterative version as well as recursive version, and also I will show you move to front operation after linear search. I am using the same program for a linked list which is having all the functions that we have already written. I am making it as a single large program for all the operations of a linked list. So here above the main function, I will write a function for linear search. Linear search function should return a structure type node. So this should be struct node, and let us call this function as lsearch, that is linear search, and it should take a pointer to a structure node, and let us call the pointer as p. And the next thing is the key that we want to search. Now inside the function we should scan through a linked list searching for a key value. So for that we can use a while loop while p that is not equal to null, or we can just write while p and check if key is equal to p's data. If it is found, then return p. We will return a node. Otherwise we will move p to next node. So it will be linearly searching, and whenever key is found, it will return that key node. At the end of the loop means it has reached the end of a loop means the key is not found, so we will return null, that is 0. That's all. This is a linear search function. Let us call this linear search function, that is lsearch function, inside main function. As the linear search function is returning a node, so I will declare a node pointer, that is temporary pointer I will take. Let us call it as a temp, and this should be of type struct node. And here inside temp, I will take the address returned by that function. So I will call function lsearch by passing pointer first and the key value that I want to search. So the key value that I want to search is 25. Let us send 25. Now this temp, if it is not null, means if temp means it is not null, then only I can print the result. So I will print the result, that is data is found, key is found at, and the key is so and so. So already we know the key, but still I will display the key. A message key is found is sufficient for us. If we have to process anything upon that key, then we can do it. But in our example, just we want to know whether key is there or not there. If temp is null, then we will print key is not found. That's all. Let us run the program. See, key is found. That key is 25. I'll give /n here so that it comes in the next line. Now, this time I will look for a key that is 17. 17 is not there in the list, so I should get a message key not found. Yes, key not found. If I give the value 7, then I should get a message key found and 7. Yes, key found and 7. That's it. This is working. So this is a iterative version of linear search. Then let us write a recursive version of linear search. Function should return a node type pointer, and let us call this function as r search, and it should take a parameter that is struct node, that is pointed to a first node, and also a key that we want to search. If p is null, means it is not pointing on any node, then return null, means the key is not found. Else it can return a recursive call to a next node, that is p's data, and also a key. That's it. If p is not null, then it should check if key is equal to p's data. If key is equal to p data, then it should return p. Otherwise, it should call itself recursively r search by sending p's next and also a key. So here also I will write return. That's all. This is a recursive version of linear search. Now instead of lsearch, I will call r search here, that is recursive search, and rest of the things are same inside main function. So I have just modified the function name, that is recursive search. I will be calling this function. Now I'm searching for a key value 7. Let us see, I should get a message that key is found. Yes, key is found. If I give 27, key is not found. Yes, here is the message, key is not found. If I give 25, then key is found. Yes, I got a message that is key is found. So that's all. This is the demo for linear search using iteration as well as recursion. Now inside linear search, I have already discussed how we can perform move to front operation so that next time when we search for the same key, it can be done faster. So for that, I have to take one more temporary pointer, that is tail pointer, and let it be q. And inside the loop, before moving p to the next node, I should move Q upon P. Already we have discussed the code, so just I am modifying based on that code. And inside if the key is found, then I should make that key node as a first node. So for that, I should say Q's next should point on P's next, and P's next should point on first node, and first should be moved upon P. See, first pointer is actually global. Here we have declared. So this function can directly modify this first. So these are the three steps by which we can move a node, key node, and make it as a first node, that is header node. Now let us try this and see. Here inside the main function, I will call lsearch function, that is iterative linear search function, which we have modified and made it as move to front. Now suppose I am searching for a key value 25, then after searching, when it is found, it should be brought as the first node. So for testing this one, I should call display function. So for testing this one, I should call display function by sending first pointer. I should get that 25 as the first element. Let us run this. Yes, key found 25, and if you look at the linked list now, 25 is the first node, that is before 3. Here I will try something. After performing linear search for 25, I will again perform linear search for one more key value by passing first, and I will also search for 8. Let us see what happens. See, first 25 should be brought as a first node, then again 8 should be brought as a first node. Then after these two search operation, I should get the keys as first 8, then 25, then after that I should have 3. Let us run. Yeah, here you can see that first is 8, then 25, then 3, then 5, 7, 10, 32, and 2. So this 8 and 25 are removed and they are brought as the first node. First time 25, then next is 8. So 8 is the latest first node. So next time if I search for 8, it will be found faster just in one comparison. So this is how we can improve linear search in a linked list by performing move to front. So these were few lines for performing move to front, and here it's giving a warning that queue is not initialized because here I have declared but not initialized, so it's guessing that it is not initialized, so it may cause any error. So we should initialize the variable. So if you initialize them, then this error will be gone. Anyway, it's not an issue. Our code is perfect because Q is initialized here. That compiler is unable to see that, so it's giving a warning. Or else we should remove this Q assign P and make it as a first statement. So it makes no difference whether it is done at this place or this place, makes no difference. So if I compile now, this error is gone. Yes, warning is gone. So that's all in this video. We have seen linear search and two versions of linear search, that is iterative as well as recursive. Then also we have seen move to front operation.